In section 8.1, we're going to be working with adding and subtracting polynomials. This should be pretty familiar territory for you. We're really just talking about combining like terms is essentially what we'll be doing. Key vocabulary in this section will be monomial, degree, polynomial, leading coefficient, binomial, and trinomial. So when you start talking about polynomials, a monomial is a polynomial with one term. A binomial is a polynomial with two terms, and a trinomial is a polynomial with three terms. Let's take a look at what some of these things kind of look like. So when we describe a monomial, it's a number, a variable, or product of a number and one or more variables with whole number exponents. So this is important, whole number exponents. Right? That means we're not going to be looking at negative exponents. Whole number exponents. The degree of a monomial is the sum of the exponents of the variables. Okay, so this degree is 0, this degree is 1, this degree is 3 because I have a to the first and I have b to the second, and 1 plus 2 would be 3. The degree of this monomial is 5. Right? A sum is not a monomial, so this is not a monomial. X could be considered a monomial, and 5 is a monomial, but together they're a binomial. Okay, two terms. This is not a monomial because you can't have a variable in the denominator. You can't have a variable exponent, and you can't have a negative number for an exponent, or for that matter, any number that's not a whole number. So you can't have fractions as exponents, and you can't have negative numbers as exponents. So when we're typically dealing with a polynomial such as this, where we've only got one variable, right, the degree of the polynomial is the greatest degree of its terms. So in this case, this would be a third degree polynomial. The leading coefficient is the coefficient with the greatest power of the variable, in this case x, and it's leading because it's always in the front if we've written the polynomial correctly, because we're supposed to write our polynomials so that the exponents of the variables decrease as we go from left to right. So you see I have third power, second power, first power, zero power. So they're decreasing. This is written correctly. And when you have it written correctly, the front coefficient is the leading coefficient. Okay, so that's why it's called leading. And then the constant term is the term with the variable to the zero power, or it looks like it doesn't have a variable part. Right? It's at the end. Right now, if there isn't a number here, then the constant term would be 0. Right? So let's just work on making sure we've got the polynomial arranged correctly. Remember, I have to have descending powers of the variable. And the other thing you want to remember is that each term in a polynomial includes the sign that is in front of it. Okay, so when I start rearranging these things, it's important that I move the sign with it. Okay, so I'll have positive 3z to the fourth, and then I'll have plus 2z cubed minus z squared plus 5z. And in this case, my degree is 4. My leading coefficient is 3. If they wanted me to find the constant here is 0 because there's nothing being added here at the end. When we work with this one, I'm going to have 5n cubed minus n squared plus 6. The degree is 3, and the leading coefficient is 5. Okay, when we look at binomials and trinomials, a polynomial with two terms is called a binomial, and a polynomial with three terms is called a trinomial. And if you take a look at this one here is a trinomial. It has three terms. And if it is a polynomial, find its degree. Its degree is 4. Okay, so this is a polynomial. So yes, it is. It's a trinomial of the degree of 4. When we look at this one, this is not a polynomial because it has a negative exponent. Okay, so that isn't going to work out for us. Right, when we want to add polynomials, we're going to combine like terms. So I'll have 5a squared plus 8a squared is 13a squared. And I'll have negative 3 plus negative 1, that's negative 4. Okay, you might find it helpful to arrange things by their type. If this helps you, you might want to take that step. I typically don't do that. Okay, if I wanted to subtract polynomials, you see I have 5mn minus 13mn. That's going to be negative 8mn. I have 3m minus 2m. That's going to be 1m. And I have negative 9n, and there's no n's over here, so that's minus nothing. So it's negative 9n. And I'm done. If it helps you, you might want to remember that when I take parentheses off after a minus sign, you could do what we did in the previous problem, but when I take parentheses off after a minus sign, I have to distribute what is essentially a negative 1 here that's being multiplied times this. So I could rewrite it as 5mn plus 3m minus 9n minus 13mn minus 2m. Okay, you should do as much or as little as works for you. Okay, including I could rearrange them now by type. So I have 5mn minus 13mn, and I have plus 3m minus 2m minus 9n. And when I take these two, they become negative 8mn. And when I take these two, they become just plus m. And this one comes over by itself, minus 9n. So you should do as much or as little work is necessary for you to do a good job. Right? I'm not going to require you to do all of these steps, but you might want to do them if you find that you're struggling with doing the work accurately. Okay, so let's take a look at this problem. I have got Major League Baseball attendance for the two leagues, the National League and the American League, and they've given me these polynomials that represent the attendance. So if this is the National League and this is the American League, if I add them together, that will be all Major League games. So the first thing I want to do is do that. I'm going to add them together. So I'll have 6, 0, 8, negative 806t squared. These two items added together will be 0, 7, 4, 8, so 8,470t. And then when I add these guys together, I'll get 300, 50,300. Okay, so now the next part of the question, they want to know how many people attended Major League Baseball games in 2001. Well, this represents the time since 1995, so 2001 is 6 years since. So when I plug 6 in for t, 6 squared is 36. And then this will be 8470 times 6 plus 50,300. If I go ahead and whip out a calculator and do that kind of work, I can have 8470 times 6 equals plus 50,300 equals, so that's 101.20 minus this value. So I'm going to put that into memory, and I'm going to do 806 opposite times 36 equals, and then I'm going to do plus, memory recall, equals, so 72,100 104. Okay, so that's the number of people that attended baseball games in the year 2001. Okay, in thousands, right? So 72,104,000, which would be 72,104,000. Okay? And that's our section 8.1.